Solid is a reactive JavaScript framework. If you're interested in what reactivity is and how it works in Solid, this video is for you. Let's say we have a relationship. Double count is set to count times 2, and we can go ahead and print that out. But if we change count and print again, the value of double count is still the same. In order for the relationship to hold, we have to restate that relationship. What Solid's reactivity can do for us is maintain that relationship over time, make it into a rule that's always true. Instead of using let, we'll use createSignal, imported from Solid, to create a reactive variable. This gives us two functions, a getter and a setter. We'll call the getter whenever we want to access the value of the variable. This gives us the same result, but signals allow us to tap into Solid's reactivity. Rather than double count being an assignment at a specific point in time, we can write it as a function of our count signal. To show how Solid can maintain this relationship over time, let's update our count signal every second using setInterval, which is built into JavaScript. Here we'll make use of that second function we got from createSignal, the setter function that sets the reactive variable to what we pass. In this case, we set the count to the value of the count plus 1. Instead of just logging double count once, we'll wrap our output using createEffect. An effect is some function that depends on signals. With createEffect, we pass a function, and Solid will keep track of any signals that are used inside the function scope. When any of those change, the effect will rerun. In this case, the count signal is used by double count, which is inside the effect, so whenever count changes, we get another output to the console. This makes reasoning about your code way easier, especially as complexity grows. Let's say we had another signal for a multiplier. Let's change that over time too. We will increment it as well at a different interval. And let's use both of our signals inside the effect to tell the user a mathematical statement. As you can see, whenever either signal changes, the effect reruns. And this system is composable. We can pull relationships out into their own functions. So we can make our code a little bit neater by pulling out the product calculation. We can pass this around and call it within effects, and Solid will always know to look as deep as it needs to find any signals and rerun the effect when those change. To sum up, createSignal sets up a value that can be tracked by Solid, and createEffect makes sure a function is always up to date when a signal that it depends on is updated. Also, you can use functions to represent relationships between your signals, giving you a powerful way to model your system. Let's take a look at how this works with some pseudocode. At the most basic level, createSignal lets us read and write to a value. But in order for reactivity to work, we need a way to keep track of any effect that observes this signal. We'll maintain a global stack called context, which will let us keep track of whatever effect is currently running. A getCurrentObserver function will just return the top of the stack. Then we make sure this context is kept up to date. In createEffect, we take a function and create a wrapper around it. The wrapper pushes itself onto the context stack, executes the function that was passed, and then removes itself from the stack when it's done. With this system in place, when a signal is read, it can call getCurrentObserver to check if it's running inside an effect. Then, it can grab a reference to that effect and add it to its subscriber list. Then whenever we write to the signal, it can go and rerun all of those subscribers. This is a simplified implementation for sure, but this type of subscription mechanism is at the core of how Solid works. Outputting to the console on an empty screen isn't that interesting, so let's create a DOM node using vanilla JavaScript here. We'll create an h1, and we'll give it some placeholder content. Then we will add it to the screen by appending it to the existing app.div. Sure enough, it shows up. Let's modify our effect so that instead of printing to the console, we update this header. Let's get rid of these set intervals too, and add buttons instead. We could write them out using DOM functions, but Solid allows you to write HTML elements directly into your code thanks to JSX. Let's add these to the screen too, using that append call to the app div. Now let's make these buttons actually work. We can use the curly brace syntax to set the click event of each button to a function that increments the appropriate signal. In general, curly braces in JSX allow us to insert a dynamic value. And now we've got a UI working, using Solid's reactive system to stay in sync with the data. But there's certainly still room for improvement. Firstly, this isn't totally optimal. Our effect will replace the entire text content of the header, even if only a small amount of that needed to change, which is costly from a performance perspective. Secondly, even though Solid cut down on how much code we need to maintain our state, we're still writing imperative code here, directly manipulating the DOM. And Solid can make writing UI code much easier using components. In Solid, components are just functions that help us group our UI code and reuse it. Let's start with an app function that will serve as the entry point for our app. We can move our signals inside of it, although we don't necessarily need to. Components in Solid return a DOM node to be rendered, so let's make sure to do that. We can go ahead and move our buttons into this div. I'll go ahead and copy and paste it. And we can remove our old header and create one using JSX. We'll just have some placeholder content for now. To tell Solid that this component is our entry point, we will use this render function that we'll have to import from Solid. It takes a component and a DOM element to mount to. This is the typical setup for Solid. A nice thing about JSX in Solid, whether you do it inside a component or not, is that it lets you use reactive values directly inside of this template. So instead of creating an effect that imperatively modifies the header, we can just interpolate values directly into the header. Behind the scenes, Solid actually compiles this into effects, but we don't have to worry about this. In fact, Solid optimizes our declarative code. Now, only the text nodes that actually need to be updated will be updated. We call this granular updates, and it's enabled by Solid's compiler. I mentioned before that we didn't have to put these signals inside the component. That's because components in Solid don't own their state like they do in other frameworks. The components just help you structure your app. And just like functions can be called multiple times, components can be reused. We could move our signals and template code into a reusable component just for demo purposes. We can call it multiplier. Then we can use that multiplier component just like an HTML element within our app component. So our app component will be this div that will contain this multiplier component, and we can actually include it multiple times. Because the component function makes its own signals, all of the components have an independent state. But if we move the signals outside of the component function, well, now each instance uses the same state. And instead of having all three components do the same thing, maybe instead we could multiply the counter by a number passed from the parent. So the first one can multiply by 3, the second one by 4, the third one by 11. And this custom attribute we're passing is called a prop, and we can reference it inside the component by using the props argument. So we can grab that prop called by with props.by. We can go ahead and remove this product function and the multiplier signal now that it doesn't do anything, and the corresponding button doesn't do anything either. But sure enough, our components refer to this counter and multiply it by a different number. I highly recommend checking out this playground yourself using this link, and I want to point out this output tab where you can see how Solid turns your JSX templates into compiled, optimized code. Be sure to check out solidjs.com where you can grab the frameworks, read the docs, check out some resources, and be sure to join our Discord, which is a super active community. We're all excited to see you there.